Here we go with our next lesson. This one's going to be on simplifying expressions. And we've got a couple learning targets here. All right, let's first talk about, before we get into like terms, let's talk about, the parts of an expression or an equation. There's a name pretty much for everything in mathematics. And the first thing we're going to talk about is a term. And right here we have a term is, in the blue box here, in algebra, a term is either a single number, a variable, or numbers and variables multiplied together. These are all terms. 9t is a term. Positive 8 is a term. 3 is a term. Those are all terms. Anything that's basically part of a math problem, a math expression, a math equation, is a term. I'm not going to call t a term. The whole thing, 9t, is a term. So those are what terms are. I mean, if you take a really simple problem like 4 plus 1, it doesn't seem like it, but those are called terms. Your teacher, when you were learning basic addition, didn't call those terms, but they are. 4 is a term, and 1 is a term. I know they're also numbers, but if we're getting into algebra, we're going to express those as terms. Coefficient. Next thing here is coefficient. Coefficient is used to multiply a variable. For example, 9t means 9 times t, and t is the variable, so 9 is the coefficient. So it's kind of a big word, coefficient. Coefficient is, in simplest terms, it's the number in front of a letter. So that is the coefficient. 9 is the coefficient. These are not coefficients. Those are terms. Well, there's something else besides terms. T, if there's a letter involved, there's going to be a coefficient. So if we had 17a, 17 would be the coefficient. If we had 3x, then 3 would be the coefficient. So in this problem, the number 9 is a coefficient. The next thing I'm going to talk about is what a variable is. And we've kind of talked about this, so I don't really need to spend a lot of time on this. A variable is a symbol that stands for a number. It represents a number or a quantity or a value. Parts of an expression or an equation is this thing called a constant. And again, that might be something you've already known or you've talked about. But constants are a fixed value, okay? They don't have a letter attached to it. They're just a plain old simple number. 8 is a constant. 3 is a constant. If I wrote a problem like this, 6c plus 1, you can say that's a constant. The number 1 is a constant. Basically, it doesn't have a letter on it, doesn't have a variable attached to it, it's a constant. You can even say an expression like this, 5x has a constant, because then you can say, well, the constant's 0. Because I can write 5x plus 0, and it would mean exactly the same thing. 5x plus 0 and 5x are the same thing. So the constant is 0. Okay, so what are the terms here? The terms, if you remember previously, the terms are basically everything. X is a term. I'm going to use comma to separate them. Positive 2x is a term. And 3 is actually a term. So terms are basically just the individual parts of it. Coefficients, what are the coefficients? Now, one thing that might trip you up a little bit is if there's a letter, like just X or A or whatever the letter is, just a lone letter, there's a coefficient there. A lot of people say, well, there's no coefficient on X. Well, by default, it's just there, it's invisible, but you know it's there, and it's the number 1. There's always going to be a coefficient of 1. So if you just see the variable A, that can also be expressed as 1A. If you see the letter N, that can be written as 1N. If you see the variable g, that can be written as 1g. So if it's just a letter, then the coefficient is automatically 1. Okay? If it's not just a letter, like 2x, then the coefficient obviously is 2. So the coefficients in this problem are 1, 2. And that's it. 1 and 2. This 3 is not a coefficient. There's not a letter attached to it. The variables, this is pretty simple. The variables is just one thing. Just an x. That's it. That's all we have for the variables. The constants, there's only one constant in this problem. It's the number 3. It's up there. And that's it. That's a constant because it does not have a letter attached to it. It's just a lone solitary number. That's it. 3. Or if you have a number like 5 or negative 2, those are constants. Okay, now next part is we're going to talk about this thing called collecting like terms. Okay, now I have a lot written down here. And make sure you write this down in your notes. But I'm going to read this with you, and you go ahead and write it down. But like terms are terms whose variables and their exponents, and we're really not going to get into problems where there's exponents. Like terms are terms whose variables and their exponents, such as 2 in the x squared part, are the same. In other words, terms that are like each other. This problem right here, we have a and 5a are like terms because they both have an a. 3b and 2b are constants because they both have a b. Sorry, I had to edit that a little bit. So those are like terms. These are like terms because they both have an a. These are like terms because they both have a b. You can only add like terms with other like terms. So I can only add a's with other a's and b's with other b's. I cannot take this entire statement and add it all up. I'm going to show you why. Okay, one way I like to think of this is, I use the letter A and B intentionally. One of the reasons I use this is because think of it like apples and bananas. A stands for apple, and so A really stands for 1A, one apple. B stands for bananas. So what we have is 3 bananas. So the coefficient 3 represents how many bananas there are. And then 5A stands for 5 apples, and 2B stands for 2 bananas. So if we add all this up, if I were to try to add this up, 1 plus 3 plus 5 plus 2. If I were to attempt to add all that up, that would not make much sense. I can't. If someone were to say, hey, how many apples are there? And you say, oh, there's 1 plus 3 plus 5 plus 2, that would not be a true statement. Same thing for bananas. All right, so you tell them how many apples there are, and you would tell someone how many bananas there are. So we're only going to add apples with apples. So 1A plus 5A makes 6A. That makes 6 apples. All right. 3B and 2B adds up to 5B. And I know that does not seem like an answer, but this is it. We have simplified this expression. We cannot do anything else with this expression unless we know what B is and what A is. But that's it. This does not seem like an answer, but that's in algebra, that's what's going to happen a lot. You're going to get answers that look like another problem. All we had to do in this problem was simplify the expression, and we got 6A and we got 5B. That does not make 11A. It does not make 11B. You cannot say that. 11A is not equal to 11B. It's not equal to 11AB. None of those things. This is it. 6 apples and 5 bananas. Okay, so that's your first exposure there to something called like terms, which in algebra is a very important concept, especially when you get into simplifying equations. Okay, so let's go ahead and practice some of these collecting like term problems and just make sure we understand them. In our first example, what we have 4x plus 3x plus 8. First thing I want to do before I start adding or subtracting anything is just kind of draw circles and diagram this a little bit and draw circles around like terms. So the only thing I can add 4x to is another term that has an x as a variable, and that's it. So 4x and 3x are the only 2 terms in this entire expression that could be added. So all we're going to do when we add like terms is we're going to add or subtract, if it's a subtraction problem. Add or subtract the coefficients. The coefficients are 4 and 3, and when you add 4 and 3, you get 7. So 7x. Okay, 8 is a constant, and there's no other constants in this problem. Maybe if I had like plus 7, I could do 8 plus 7, but we don't. And so that just goes down and becomes part of the answer. And that's it. That's all you can do. I know that does not seem like an answer, but that is your answer. We have simplified that expression, just like a fraction gets simplified to lowest terms. We have simplified this expression into simplest form. Okay, in the next problem here, number 2, we have 9. 9 is a constant, and I can only add constants with other constants. 9 and 2 are both constants. That's it. 9 and 2 makes 11. And I have 15h. I have a term here with a letter. 15 is the coefficient of h, and there's no other term in this problem that has an h in it. If I had, for instance, plus 9h in there, then I could do 15 plus 9. I can add those coefficients up, the 15 and the 9, but I cannot with what I have so far. So that just drops down and becomes part of the answer, the solution. 11 plus 15h, and that's it. The only thing we could add were those constants, 9 and 2. On the last problem here, we're going to add as much as we can. So we've got 3c, and all I can add 3c to is another thing that has a 3c. Now I'm looking, is there a 3c anywhere? Or is there a c anywhere? And I don't see any. And let me look at the 11n then. Let's see if there's any other n's in this problem. And there are no n's. And you probably have already figured this out, but there's no other p's. And this may seem like, it's not true, but that's it. This is already in simplest form. So sometimes when you're dealing with expressions, there's nothing you can add. There's no like terms. The only thing that can add up with a c is another c term. There's no other c terms. There's no other n terms. There's no other p terms. There's no constants to add in this problem. So that's it. You're done. You're finished with that problem. Doesn't seem like it, but that's it. You cannot do any more with it. Okay, so that does it for this lesson. I hope everyone understood it. There's a lot of new things we talked about. Coefficients, terms, constants, collecting like terms. So a lot of new stuff here. Not necessarily difficult, but new. Make sure you guys get this all in your notes, and I'll see you tomorrow. Everyone have a great night.